recording. All righty. So, part two of air conditioning. Welcome. Those of you watching in the recording, again, hopefully, whenever time you're watching it, thank you for watching the mobile air condition. Hopefully, you saw part one. We introduced air conditioning. We said that air conditioning cleans, cools, and dries the air. We saw that the AC system has a pressure temperature relationship with the refrigerants. And we saw that the 134A along with the 1234YF have similar pressure temperature relationships, so they're not too much varied. So if you've been following, we were under the impression years ago when 1234YF came about, we were told that the 1234YF was going to be pretty much in everything. So I haven't gotten no good straight answers on this, and maybe I'll reach out to Max later on, Mobile Air Conditioning Society, of what we're looking at, because carbon dioxide seems to be the new trend of the future of refrigeration or mobile air conditioning. So therefore that's what we're looking at. But hopefully you got to see the part one. And if you haven't, like once again, I'll be sending out a link from YouTube because I had to put it there for the meantime till I fix the problems with Zoom and on the Uscreen program that I use. But anyways, we'll figure that out. So in the review of what we talked about on part one, we saw the low pressure side indicates the temperature of the evaporator. We showed you a gauge on part one, and we were talking about how the temperature is related to actually the pressure. So when I look at the low pressure gauge, I actually will look at the gauge closely, or I can have a pressure temperature relationship chart if I want it there, and I can understand what the temperature is. Now I know we're trying to make it basics. A lot of us will touch that low line going into or out of the evaporator. And what we do, we feel if it's cold, right? That means there's something going on there. But in this case, the pressures are very important, and we got to be careful how it all works. But what I want to pretty much review here is the fact that airflow, both on the condenser side and on the evaporator side, is everything, especially on the condenser side. Yes, we want cold air to the face, like we said already. We talk about the HVAC system on part one, but we have to understand that airflow is the biggie. So if you were to look at a refrigeration system and like what you see here, the air conditioning system, you often ask yourself, what is it that I can enhance to make it even blow colder? For example, we get modified vehicles, like we got this guy years ago that actually wanted his van to blow really cold. What was the one thing that we did replace? And that was the condenser. We're wanting to get rid of that heat from that refrigerant and actually have it get colder and provide better cold temperatures. So in this case, we're trying to get rid of heat. So as much as the evaporator is absorbing the heat and giving you away cold, the condenser is giving away the heat. So therefore, again, airflow is very critical. So when guys do modifications, and I don't know why, like I'm on the PowerStroke 60 forums, and the guys want to put electric fans on there, when I think the viscous fan clutch that comes from the factory works just great because it's on my truck, I know. So therefore, what I'm trying to say is airflow is critical. So is that fan turning on when they turn on the air conditioning? Because again, you need to have hellacious amount of airflow going across there. And then it manages itself because as the vehicle's going down the road, we don't want that fan to be kicking on as much because the ram air is supplying that air as you're going, let's say 70 miles an hour down the highway. But again, what I need you to understand is that airflow, like I said, airflow and having a clean condenser, no obstructions in the front, an air conditioning system. So as you visually look at an AC, like I said in part one, definitely want to verify, does it have a high or low speed fan? I don't know what kind of application you're working on. If it has that, then at that point, make sure those fans are turned on to test again that AC is getting the full, getting rid of that heat as much as possible. So again, that's what we're looking at. But again, like the title says of this slide, that low pressure side is going to be your best friend to tell you what's going on with that evaporator, because there have been cases, very few, but I'll still say it, where I'm getting a low pressure, I'm getting around 36 psi, and that's pretty cold. Okay. And the thing is, reading 36 psi, the high side looks good. And in this case, it's blowing warm air. And turns out that the motor for the heater was actually stuck, meaning that it was not in full closed position to the heater. It was open to the part heater core. So therefore, it was heating the incoming cold air. So therefore, you got to be aware that the motor could be it. And I've seen cases where guys were, say, hey, I got something wrong with the refrigeration, still blowing warm or blowing lukewarm. And in this case, it has nothing to do with this refrigeration system you see here on the slide. It has to do with the HVAC doors not fully closing. In other words, the low temperature door, as I like to call it. So in review, before I continue on, what is the function of an air conditioning system? Like I said, clean, cools, and dries the air. Name the contaminants of an AC system that we measured in part one. Well, air is a biggie, right? Air is a biggie. Too much oil, right? Too much oil could be a factor. And in this case, or maybe the wrong oil too. God forbid they use the wrong oil, but in this case, the oil can be the situation there. And what other contaminants can we have? Well, we mentioned in part one about maybe looking into an identifier. Since Las Vegas, where I'm at, is a big transient town. Yes, it is a transient town. There's the I-15 that goes north and south, and we get vehicles passing through. I could have Wisconsin plates, Washington plates, different states or countries actually coming in through Vegas, and you don't know what they have in it. So therefore, having an identifier to make sure you have 134A or the 1234YF. So therefore, you definitely want to do that. Not to mention the biggest contaminant, like I said, is air. So therefore, be aware air can be a problem. So we talked about the vacuum pump, and we told you about the test. I was actually going to search for my mason jar that I mentioned in part one about testing a vacuum pump, see if it boils water. We talked about that. And in this case, definitely want to test your vacuum pumps, because again, if it's not actually boiling or getting the moisture out, then therefore we're going to have a problem. And those of you that live in high humid areas, this is a problem because you need to do more maintenance on that vacuum pump. So we'll review that as we move along. But hopefully by next week, when I teach part three, we'll have the jar ready. I'll have it showing to you how we do it here in our area, because I can't find my jar, but that's another story in itself why I can't find it. But anyways, and what are the types of refrigerants that we have? Well, there's 134A, and then there is the 1234YF that is used on other vehicles out there as well. So therefore, yes, 134A is still around, hasn't been completely phased out. The price is dropping. It was high earlier this year. Like I said in the last class when I called the local auto parts here, it was at 289, 830 pound pound container for 134A. So therefore, it isn't as high as it used to be because it was higher than that. And what is the average oil capacity of an AC system? Anybody remember? It was somewhere around what? About 8 ounces, somewhere around 8 ounces, if you remember. So in this case, we got to watch the oils, because like I mentioned, those customers that might want to service their ACs and they still can't get it working, they finally bring it to you. Please note that they can over oil the system very easily, because those little quick shot bottles that you could buy at the local auto parts, some of them contain oil. So they'll just keep adding and adding and adding, but at the same time, they're adding a lot of oil into the system, which again will affect the efficiency of that refrigeration system to be able to blow cold. Now, as we look at the screen here, you're going to see that, like I said, airflow is everything. I stress that again. Yes, I repeat things when I teach, and that is we need that airflow going across that condenser and the efficiency of the condenser. Now, when I taught AC over 20 years ago and I taught AC now, there's a lot of new tools out there. For example, your infrared temperature probe, where you could have that screen where you could see what's going on. Depending what the access you got to the condensers, those are a very valuable tool, because in the past, when we still can have it happen, where we can get an evaporator that's partially clogged. Let me give you the scenario. The system takes 2 pounds, let's say, and you charge the refrigeration system and it won't take no more than 1.5. It won't take the 2, but the specifications say it takes 2 pounds. Why would it not take the 2 pounds like the way it's specified? No, it isn't that there's something stuck in there. It means that it's restricted. Either the condenser or most likely the evaporator has a restriction in it. One of the passages is clogged, most likely from the desiccant or metal from the compressor, but most likely desiccant from the receiver dryer / accumulator might be stuffed in there. So therefore, what a lot of us would do is we'll look at we can actually look at the evaporator inlet and outlet and see what the temperature variances are. But even though it's working with 1.5 pounds, even though it's supposed to take 2 pounds, it'll still work decently, but you just lost the equivalency or the ability to use the full capacity of that evaporator. So if I have access to that evaporator, like some have a bottom tray which you can remove and you could see the evaporator on those models, not all models, you could actually put a temperature infrared gun. You could see where the restriction might be at. So that's the new stuff that makes it easy. The question is, do I have access to it? Because like if I work on a Ram Dodge, you can't get to nothing there. You got to pull the whole damn thing just to see the evaporator. So I understand that. But we can also use our temperature probes to look at the inlet and outlet of that evaporator, see if we do have a change in temperature. Now, the big thing you got to understand, as I will get into the compressor side of things here, is that the compressor does not like liquid. It'll hydrostatically lock it. So if you want to destroy a compressor real quick, that actually will see a liquid. It should not see a liquid on the suction side. So we'll get more into it. I don't want to jump ahead so fast. But yeah, the compressor needs to see that. But what moves the refrigerant, like we said in part one, is the compressor. So the compressor not only generates the pressure that we see on the high side, but it also creates a suction which creates a low pressure on the suction side. So the compressor has a big job. Not only does he moving that refrigerant, the refrigerant is moving the oil, but again, he creates the high pressure and he also creates the low pressure, but he cannot create a high pressure unless he pushes up against something. He's got to have a restriction, something that he pushes up against. So therefore, that would be the orifice tube or the expansion valve. Like we mentioned in part one, there are basically two styles of refrigeration systems. That would be expansion valve type, or that would be orifice tube. Ford has been known to use orifice tube in the early stuff, and now they're using expansion valves now. GM also the same thing. They've been using orifice tubes, but also have moved to expansion valves on certain models. So therefore, it can vary. Okay, so the imports like the VW, TDIs, and so on, those definitely use expansion valves there too as well. But we're pushing up against this. So as we look at this diagram, we'll see that the compressor on the outlet, you're going to see the refrigerant. It is red in color, but what it's supposed to do again is condense, meaning that to word condense means to go from a vapor to a liquid. We're condensing. But in order to do that, we're going to go ahead and get rid of heat. So therefore, we're getting rid of heat. And in turn, that refrigerant will be in a liquid state going towards the expansion valve where it's going to be regulated its flow. And then at that point, we go into the evaporator where pretty much warm air is going across the evaporator. We're carrying and absorbing that heat. And at that point, we're taking it back towards the compressor, then on the circulation or the repeat fashion here is taking place. But I guess what I'm gonna get it really hard and heavy to make you hopefully understand that a lot of people don't think about, maybe you got it, maybe you don't, is that the refrigerant itself, whether it being the 134A or the 1234YF, is the actual carrier of the heat. Okay, so therefore, if you're gonna boil water, for example, let me change my subject here for a second so I can make my point with refrigerant. If you're gonna boil water, that means that water, when it boils and you see the vapor coming up, you got to understand that it's got heat, and in order for it to stay in a vapor state, it's got to stay warm. But when it cools down, it goes back to a liquid, right? But what I'm trying to make my point is that since the refrigeration system is all sealed assembly, if you will, that means that as that refrigerant goes into a gas or a vapor, that means it's got heat with it. So by the time it goes to the condenser, that refrigerant is giving up that heat and condensing itself back into a liquid. So therefore, it is the heat carrier. So when you look at the vehicle compartment, you're in recirculation mode, and you're recirculating about 90% of that air inside of the vehicle compartment or that truck compartment. That means that heat is actually being carried by that refrigerant. Okay, it's carried by that refrigerant, and it gives it up at the condenser. So as much as you feel cold air, in your face when that air conditioner is working properly, you got to understand that we're also taking that heat. So therefore, what happens to the refrigerant in the evaporator is that it actually turns into a gas. So the proper charging, the proper oiling makes this happen. But like I keep saying again and again already today, is airflow is critical. So therefore, that airflow needs to be proper going across that condenser and along with the blower motor too as well. So again, one more time, heat is needed to boil that refrigerant. And that's what occurs in that evaporator. It turns into a vapor. And like I told you already, that compressor will only take that refrigerant in a vapor state or gaseous state. Then it compresses it or pressurizes it. And again, it goes out as a vapor, but it condenses into a liquid in the condenser itself. Okay. Very critical to understand that, because that's where you're going to be dealing with AC systems that are not blowing very cold. And even though you charged it proper, you check the oil, then we need to look at why is that occurring? Could it be an expansion valve stuck or not? So, but we got a few video clips that I took yesterday actually of the vehicles I actually serviced just to show you some few readings. So repeating the components were the compressor, the condenser, the orifice tube, the evaporator, and the dryer accumulator receiver dryer. Now, for those of you who don't know, we'll get into dryers really in depth in part 3, but the receiver dryer on expansion valve systems, that's the one we use, as you can see there on the picture there, is used on expansion valve. But you're going to notice the receiver dryer with an expansion valve system is on the high side. It's on the high pressure side, while the accumulator is on the low pressure side before the compressor. So the accumulator dryer it actually serves two functions. It absorbs moisture just like the receiver dryer, but it also ensures that nothing but vapor goes back to the compressor. So that in essence, it protects the compressor. So even though they're similar, the accumulator and the receiver dryer, they absorb moisture. They have desiccant bags inside of them to absorb that moisture. The accumulator dryer takes it a step further. It ensures that only, again, vapor goes back to the compressor there too as well. So now the receiver dryer in the past, I'll get more into it later, had a sight glass in there and you were looking for bubbles. Guys were actually using that for proper filling. But the proper way to actually with your recovery machines is to actually use the machine to weigh in your refrigerant charge into the vehicle. So now, like we were talking about the compressor, the suction side of the compressor only takes in a gas, like we said already. Hopefully you can understand that. So that means all that refrigerant must be what? Must be boiled in the evaporator. So what if it's a cold day? How do I know that that refrigeration system is not going to send any liquid? Maybe we didn't boil at all. We didn't have enough heat, right? Well, that's where the orifice tube comes in with the accumulator. The orifice tube is a fixed tube, in other words, a fixed resistance, or shall we say an orifice. But the accumulator, like I just mentioned, is going to protect that compressor from taking in any liquid. So it's going to keep the liquid in there. Okay, so it's only going to take gas. But on a thermostatic expansion valve, it's monitoring the outlet of the outlet of the evaporator. So therefore, he's monitoring the temperature. If it's too cold already, he's going to restrict the flow. And we're going to see that on the low pressure gauge as we move along. So therefore, that's what we see going on there. So like it says on the third bullet here, the thermostatic expansion valve systems regulate or meter refrigerant to ensure that all refrigerant returns to the compressor in a gaseous state. So therefore, it's actually opening and closing and opening and closing. Where it gets bad is where it actually gets stuck open or stuck closed at a given position. Now remember that the compressor pressurizes the refrigerant and it circulates it and the oil. So there, like I mentioned in part 1 of this presentations, was that the oil is snotty, the PAG oil, the ester oil, it's snotty, it's not in solution the way mineral oil was with R12. So therefore it doesn't move readily as we see like we see with 134A compared to R12. So now the compressor itself, like I said, repeating, is that it actually pressurizes the gaseous refrigerant. But when on part 3, I'm coming up with some animation here that I'm trying to get for you, is that there are basically two different styles of compressors. There's your piston style, like you can see there on the picture, but there's also let me minimize this so I can see it myself too. So therefore, there is, again, the piston style that you can see it with the swash plate moving back and forth. But then there's also your variable displacement compressors. In my opinion, those are the best compressors, the variable displacements. They've kind of taken an absence. Now they seem to be coming back. They use them in different manufacturers for the longest time. Is because the beauty of a variable displacement compressor was that it never cycled. You see the compressor kick in and kick out. Like my Toyota Tundra right now that I'm driving right now, that thing sucks. I mean, when you're going up, when you're going Excel, you can feel that compressor kick in and kick out. You literally feel it. While with a variable displacement compressor, it actually will vary its displacement. It'll stay engaged, but it'll actually vary the stroke of each piston. So it has the ability to do that using what we call a POA valve, meaning pilot operated absolute valve. So therefore, those to me are the best. So when I talk to guys that are building custom vehicles and stuff, and they want to put AC, I said, get a variable displacement compressor. Those are the ones that you won't feel the surge on the compressor kicking in and kicking out when the either high pressure or low pressure. So Note that the suction, as the compressor sucks in, it actually is creating a low pressure. And like we mentioned in part one, the low pressure lowers the boiling point of the refrigerant. So therefore, by lowering the boiling point of refrigerant, it will actually boil easily. But again, it's going to carry the heat. So remember that as you create a suction on that low pressure side, it actually is going to lower the boiling point. So at that point, this means all refrigerant must be in a gaseous vapor state on leading to the compressor. That's about the fourth time we say that. And when the compressor pressurizes and discharges the refrigerant, it raises the pressure of the refrigerant, which again allows it to turn back into a what? Into a liquid. So the compressor pushes against the orifice tube or the TXV, depending which model of AC we're working at. So like we've been saying, here's another picture that I found that we could be using. And in this case, like I said, we got airflow going in here. We got the evaporator right there. We mentioned about on part one about any contamination or dirt. We did mention about cabin air filters can also be clogged too as well. We did that. But what I'm trying to show you here is that this is using an orifice tube system, unlike the thermostatic expansion valve. So the name itself is telling you there's an orifice there. So therefore that orifice is creating a restriction. So therefore the compressor is pushing. So this must be the outlet as we follow the arrows. This is the outlet going out. So therefore it pushes up against the orifice tube. So if the orifice tube is totally blocked, and let's say there was contamination there, if it's totally blocked, then therefore that's going to raise your high side pressures and it'll kick out eventually with the high pressure cutout switch that we use. Now, you'll notice that they're showing an AC inline filter kit. Here's the problem. Let's say you're diagnosing a truck with an orifice tube, and that orifice tube, you pull it out and it's got a whole bunch of junk in it. Now, you're going to have a dilemma here. The question is there still junk in the rest of the system? Is it stuck in the condenser? Is it in the evaporator? Maybe the accumulator? What do I do, right? So in this case, it is a wise idea to look at the accumulator. And the accumulator usually on most accumulator systems is the easiest component to remove and look at it. So we can drain it to see the oil content, right? We can drain the oil. So let's say the system takes 8 ounces and I take the accumulator off. I'm looking for any contamination. But then as you pour it out, you're going to see metal flakes or desiccant material coming out. That, yeah, you definitely have to replace the accumulator. Now, a lot of people in the past were using flushing systems where they were flushing the AC system out. Now, this is something that we went through back in the day and we still see from time to time is you can put a flush system, like one company did a video, and what they did is they flushed away the manufacturer of the flushing agent told you to do. Let's flush it out. But the problem is, before they started the flushing event, they actually weighed every component from the evaporator to the lines to the compressor to the condenser. They weighed it. And what they did is after the flush, and they did it per the flush, they did everything the way it was asked to, everything weighed more, which said that there was still remnants of that flushing agent still in the system. In other words, you can't get it out. So the consensus was, should we be using a flushing agent? So therefore, what you're going to see here that you can buy and install on different AC systems, there is filter kits out there. There's AC inline filters. Just Google it and search them. You're going to see that many vendors sell filters, whether it being a pancake style, big old flat one, or the sausage style. There's many different styles. But believe it or not, you can cut a line and you can actually put in a filter kit in the event you're trying to protect the compressor, because we have seen cases where guys have replaced compressors several times because there was still contamination such as metal or other desiccant material in the system that's just destroying especially the compressor itself. So therefore you may want to take interest in installing. So if I do pull an orifice tube and that orifice tube is full of metal or full of whatever, yeah, I'm going to try to see what I can get out of it. But if not, then maybe it's time to put an AC inline filter kit, because you're trying to protect the number one component there that has the moving parts, and that would be the compressor, and that's what you're trying to do.
Hey,
So
Tony.
definitely take interest on that. I'm sorry, question?
Yes. Can you hear me?
Yes, sir.
Okay. And the echo's gone now, correct?
Mm-hmm.
I turned my computer sound off, so that eliminated the feedback.
Oh, okay.
Anyways, doesn't the AC accumulator have a filter in it?
Some do, some don't, and it's just a chintzy screen. If you ever looked inside of it, yeah, you're correct. It does
Yeah,
have a
okay.
screen, but if it's very fine, it's going to get through that screen.
Right.
Because from time to time in the past, like last year I did like 4 or 5 compressor jobs where the customer was infuriated with another shop, and sure enough, as soon as I took the manifold line or the combination line off the compressor, it was just saturated with metal. So therefore there are other kits too, since you're talking about screens, that you can install, because the aftermarket has a lot. There's many different companies like Murray and so on, that you can actually put a screen on the inlets of the compressor too as well to protect the compressor. But to me,
Uh-huh.
I think the inline filter kit is much more, shall I say, easier. So you can do that
Yeah, I've
too.
tore a few of those accumulators apart, and it seemed to me that the ones that I did do had that desiccant bag in it that I thought kind of acted as a filter for like big particulate, metal or something like that.
No, it could. It does have. It does. It has the ability to stick some of that metal. But like I said, some of this metal we get is so fine. If you ever look what happens, like on an orifice tube, the orifice tube's always been the telltale, and you can see that
Right.
fine metal, and they'll still go through. So therefore, that's why those filters are better, in my opinion. So
So
because
in
again,
general, don't trust the accumulator to be a filter.
no, that's never
Okay,
been
very good.
mentioned. It can, but it's never been mentioned to be the filter. No, his job solely on the accumulator on this application is to merely just absorb moisture and also separate the liquid from the vapor to ensure vapor only goes back to the compressor.
Right. Okay, very good.
Okay, so definitely want to look into that. AC Delco in their catalog also has those filters available in screens. So like I said, we have a facility here in Las Vegas called Auto Air More. They're like the go people here in town that sell nothing but AC stuff for trucks and cars. And they stock all those filters and stuff. So we kind of got easy. I don't know if you have one in your local area, but in this case, yeah, AC specialty shops are nice to have because they stock all that. If not, you can order them through your auto parts there too. So but definitely, because I get frustrated, it's very frustrating that, a customer pays for a full AC rebuild, meaning that the compressor was replaced, the orifice tube was replaced, or thermostatic expansion valve, maybe a condenser and the accumulator receiver dryer, and it's that, it won't go no more than 6 months. You see catastrophic failure again, the compressor, because again, there was still evidence of contamination that took out the compressor. So what's the best security device? Like I said, is some type of inline filter, especially if it's had that happen. So I am not going to do a compressor if I knew that orifice tube or that system was contaminated. So therefore, definitely want to protect it by putting some type of filter or screen on it. You name whatever you want to put in, either the screen on the inlet on the manifold assembly of the compressor or on the lines themselves. So definitely can do that. So if the AC does stop working, that has happened here. A while back I did a compressor job. I did compressor receiver dry and orifice tube, and we put a filter on it because there was a lot of contamination. I don't know if it was still in the condenser or the evaporator. That the AC quit working 2 weeks later. The customer brought it, and sure enough, that filter was clogged. So all we had to do was evacuate the system and replace that filter and put a new filter in, and he was good to go. So it was a lot cheaper to do that inline filter than it was to replace the compressor. So, and you know that some compressors are buried and are no fun to get to. So, all right.
Yeah.
Okay, good. I'm hoping you answer your question there. So, like I said before, though, what do you need to turn a liquid to a vapor or a gas? Well, you need that heat. So therefore, you got to absorb that heat from the evaporator. That's the job of the blower motor. And again, we're giving up that heat at the condenser. Now, as we look closely here at the orifice tube, you got to understand that there's different sizes. Some guys cheat, and there's this old cheat method because if you know orifice tubes and you've seen catalogs of an orifice tubes are color coded: white, orange, red. I can't remember all the blue. There's blue too as well. And in this case, I'll try to get you a catalog image next time, but the orifice size that's inside of the plastic housing, because as you look at the picture there on the upper right, you're going to see that there is the orifice tube itself. The plastic with the O-rings is what seals it in the tube, but the actual orifice is in the center of it. Okay, it's in the center of it. So therefore, those can vary in size. That's why they're color coded. I haven't checked it lately, but it is available. So if I make the orifice smaller, you can actually raise the high side pressures. But since you created such a high side, that means that refrigerant will be able to actually run colder. A lot of guys cheat that way. So many people say, well, this is not the correct, orifice tube that calls from the factory. You're right. But a lot of guys will cheat. But the problem is when the orifice becomes that narrow opening, as you can see there, gets smaller, what's going to happen is that you raise the high side pressure, as you can see in the arrow. The high side pressure will go up because you created more of a restriction or a narrow opening. But at the same time, when it goes out after the orifice itself, as you can see here on the low pressure side, that means that that refrigerant will be able to absorb more heat because you raise the pressure so high. Now at that point, it'll be able to take more heat, which in turn will turn into the vapor much more readily. That's a cheat method a lot of guys have done to get it just a little bit colder. You could do that, but obviously I'm at the opinion that you could use the correct orifice tube for the correct vehicle. But again, that's a quick cheat method because anytime you raise the high side pressure very high, you're now compromising the life of the compressor because the life of the compressor is going to be based obviously on oiling and proper charge and no air, no contamination, but it's also based on how we try to keep that high side pressure as low as possible. Now it's going to run hot when it gets very hot. In other words, like this week here, like it's getting over 115. Yeah, it's normal to get high side to see a whole bunch, but it is going to be able to cool very, very well. But at the same time, that compressor is working much warmer. So therefore, definitely oiling is a big deal. So what am I trying to do with these squiggly lines? I sorry about my my design here, but I couldn't find a good picture that it would work, so I had to make my own here. The straight line represents the liquid refrigerant. The little circles right there represent that what is occurring to that refrigerant as it starts to cross the orifice tube. Well, it's going to see a pressure drop. And as the pressure drops, the boiling point actually drops. So therefore, some of that refrigerant will start to boil. So eventually when it goes past this tube and goes into the evaporator, it's going to start to actually boil, but it's absorbing heat, like we said already. So therefore, that is normal of an orifice tube system. But the farther the liquid travels through that orifice tube, the more it stays in the liquid state, the more apt it is to carry more heat out of it. So I guess what I'm trying to say is there is a cheat method where you can put a more narrow orifice tube in a vehicle to make it actually colder. So therefore you can do that. Okay, so it does work. You'll squeeze another 2 to 5 degrees maybe, if that. But in this case, it does work. But again, you are compromising what? The compressor. So therefore, make sure you got good airflow across that condenser. Since I talk about my vehicles and other customer vehicles too as well, like when I drive a 6.4 or a 6.7, that viscous fan clutch, I could actually see that fan turn on and you could watch that high side gauge drop a little bit. And it's normal because that fan is those trucks just move air. And in this case, since they're moving air across there, it does cool down that condenser very quick. So it works much more efficiently. So therefore, it definitely does help. But in essence, though, what I'm trying to just to mention here, the orifice tube is a fixed orifice, right? So therefore, it's not metering the flow of the refrigerant. It is an orifice, the compressor pushes up against us, and that's it. While the expansion valve can vary. So as we look at an thermostatic expansion valves vary in design. The old school style are like the ones you can see here on the upper right. Those are the old school ones that had the sensing bulb on it. That sensing bulb would be clamped to the outlet of the actual evaporator. So therefore it was doing that. But on the block style, which pretty much most manufacturers now have gone to, we see this block style. That's the block itself, as you can see there. And you're going to see from the arrows that we have the high pressure side and we have the low pressure side, because what it's going to do is it's going to meter the refrigerant going to the inlet of the evaporator. And it's going to also, again, control the what? It's going to also monitor the outlet temperature. So it's going to see what's going on the outlet of the evaporator. So let me repeat this again. Sorry if I didn't say this right. It's going to meter the flow from the compressor to the condenser. So that's the arrow coming in here. And then it's going to actually, again, monitor the temperature on the outlet. So let me get my little highlighter here, Goins here. So therefore, actually, I'm going to use a different color here. But in this case, here we can see, here comes the refrigerant right here. And you're going to see that it's actually being metered by this ball valve. There's the ball valve right there. And then it goes to the evaporator. Now it goes to the evaporator, blower motor goes across the evaporator. Here comes the refrigerant, which should be ideally all of it in a vapor state. And here it's going across this sensing valve, or that's going to affect this pressure in this diaphragm. And what it's going to do, it's going to sense the temperature right here, which is going to move which direction this ball valve is going to open or close. So therefore, the position of the ball valve is based on what? This ball valve right here is based on the temperature of the outlet of the evaporator, which we sense right here. Okay, that's what we see going on there. So in itself, it meters that flow. So it's going to open the restriction or close the restriction here on that ball valve that you can see there. So I think it's pretty unique. So let me just show you here. Let me skip a few slides. Let me show you over here. Here you can see, and let me mute the sound here because I'm going to try to, oops, let me change this around. I don't like this about. There we go. All right. So what I'm going to show you right there is, there you can see here, hopefully this recording is long enough, but you can see it. We're holding at 30 PSI. This is a TXV system. You see the pressure rise, the ball valve closed. Ball valve opens. What happens? This is a perfectly operating TXV valve, by the way. See how the pressure goes up and down? High side stays steady at 250. That's telling me that that thermostatic expansion valve is what? Is opening and closing that ball valve, if you will. So that's normal to see. So the truck, the vehicle, this is a TDI VW I did yesterday. And you can see that, again, the pressure rises, the restriction, the ball valve closed. Ball valve opens a little bit, then closes. So it's varying, again, monitoring that outlet temperature. So I guess what I'm trying to show you by you looking at this, hopefully you can all see it, is that if I'm analyzing a TXV system and I'm holding the RPM at a steady RPM, I was holding it at 1200 RPM, and I pretty much have cooled, it's pretty much blowing nice and cold across the dash. I want to observe the performance of that TXV. This is what should be happening. Because again, it's going to get cold and eventually has to close to control the flow of that refrigerant. So again, that's what we see going on there. If I'm working on a TXV and it's fixed and it stays fixed and never changes no matter what I do with the RPM, I spin the compressor faster, then therefore I could have a stuck thermostatic expansion valve. Now I'll tell you a trick that I do. A trick that I do on some stuck TXVs, I've been known to unstick them. What I have done is that I'll have my water hose ready with cold water, and what I'll do is that I will actually spray the front of the vehicle, the condenser, with cold water. In other words, from the water hose, because it's pretty cold out here. And I'll spray it across. So therefore, now I should see the high pressure drop, okay, because I shot across the condenser. That refrigerant is now subcooled big time. It's in a liquid state, but it's going to try to run mega cold for about, for about 20, 30 seconds. I should see at first the low pressure gauge drop, then it should rise dramatically. That's telling me the TXV is responding to it. So therefore, I have been known to unstick them. So if they're stuck, sometimes a sudden subcooling event with water going across the condenser will shock that TXV and all of a sudden unstick the TXV valve. Next thing you know, it's working pretty good. So therefore, that's what I've done on some TXVs. Now, if it don't change, then therefore at that point, yeah, we need to replace the thermostatic expansion valve at that point because I know it's stuck. It's not moving at all. And that's what can happen. But that's an old trick that I've been doing for years that I actually will do that. But again, what I'm trying to show you here by this video right here is I'm trying to show you, again, the TXV should be actually, again, regulating that flow with indicating to you on the low pressure side that the pressure rises and drops just like you see there. So hopefully that helps you get a visual on what you're looking for on a thermostatic expansion valve system. Make sense? So yeah, this is definitely a good TXV that I see open. That's normal to see. Okay. Hopefully you can see that on the video. So there you go. All right, let me go back to where I was. So therefore, the thermostatic expansion valve, like we said already, let me erase this stuff off of there. So, so once again, that ball valve is open and closing because this diaphragm is sensitive, expands or contracts to lift the rod, which in turn seats and unseats this ball valve either to opening more the orifice or less. So that's what we see going on with these block style there. So now I got to tell you though, sadly though, there's a lot of cheap air conditioning parts sold out there because I have put on these blocks from the local auto parts, Joe Blow name brand, and guess what? It's not regulating properly. So therefore, at that point, definitely did not see the change like I see, where we're going up and down. So I had a deficient or a rather crappy expansion valve. So I had to go with another one. So please note, not all expansion valves are the best quality in the world. So definitely pay attention to that. Now, why is this important to understand? We saw that the orifice is a fixed orifice, right? So therefore that doesn't change. Therefore, if it's a cold day or fairly cool day, and are you going to boil all that refrigerant? Maybe not. So therefore, like we said, that compressor does not like that liquid. So therefore, like we said already, the accumulator is protecting that compressor from ensuring that only gaseous refrigerant goes back to the inlet or the suction side of the compressor. But on the expansion valve, we don't use an accumulator. So that means that what ensures that all refrigerant gets boiled, if you will, ensure that only gaseous or vapor refrigerant goes to the compressor is this expansion valve. So if you have a compressor that's locked up, it grenaded, it's metal, you take it apart metal, then you need to understand that what probably took out the compressor, liquid did, because the the ball valve was probably stuck in too open of a state, so therefore it was allowing too much refrigerant. So as much as we use the expansion valve to control the flow of the refrigerant, ensure you get the best efficiency in the evaporator, it also is ensuring that there is nothing but vapor going back to the compressor. So the rule is, if that compressor is actually grenaded, you need to ask yourself, why did it grenade? Was the clutch the issue, or did it actually ingest, some liquid in that it destroyed it and grenaded it? So that would mean that maybe the expansion valve might have been the cause. So actually, most likely was the cause there that you could see there. So definitely want to pay attention to that. Okay. Any questions there? So again,
No question.
all right, good. Not good, but okay. So as we can see, the old style expansion valve, which is still used by many different manufacturers, you're going to see that they put the sensing bulb on the outlet here. And in this case, that sensing bulb has expandable gas that's going to again open and close an orifice or another ball valve, if ball sealing here on the expansion valve to regulate the flow here. So many of us would probably agree that the expansion valve is the more efficient of the systems versus orifice tube, but it's a little more costly because orifice tube is cheaper to make. It's just simple as putting an orifice in it. But again, this works efficiently to ensure as that airflow goes across the condenser, the evaporator actually will vaporize itself. So again, that air is going to blow across it. The refrigerant will absorb that heat and it'll take it all the way out to the condenser. Now, since I have this all in front of me right now, the condenser itself varies in design. Okay. For example, from my old days when I was working with GM, Silverado, the Silverado Suburbans, the Suburbans, not the Silverados, the Suburbans had a dual air system. Okay. We'll talk about dual air in part 3. But in this case, those dual air systems, they were using orifice tube in the front and they were using expansion valve in the back. So in this case, one compressor, but the regulation of flow for the evaporator in the back for the rear air was expansion valve, while the the accumulator dryer was used to protect on the compressor on the front AC because it was using an orifice tube system. So therefore, the return of the suction side of the compressor had an accumulator in it. But what I'm trying to say is you can have a combination system where you got orifice tube and expansion valve on a dual air system that you're going to see there. So definitely want to do that. Now, the other thing I want to get to is not all condensers are the same. So therefore, many guys are very frustrated by a vehicle not running as cold. And in this case, what you can do is there are aftermarket condensers that actually have smaller passages and actually hold the refrigerant longer in the condenser because it's got so many passages. Because the longer you keep it in the condenser, the more airflow is going to go across it, the more heat you're going to release. So therefore, you can modify them if so need, especially on, specialty vehicles or whatever you might encounter. So therefore, if the customer says, hey, man, this thing's, it blows cold, but not cold enough for my temperatures, blah, blah, blah. What can I do to modify it? And that would be is that you got to modify the condenser. So therefore, the condenser is your number one component, provided, once again, you got good airflow going across it. So here we could see the expandable gas in this bulb, or like we call it, the bulb that's clamped to the outlet of the evaporator. And in this case, you can see that it's regulating that flow of that refrigerant up and down. So that's what we see there. But always remember, again, the compressor, in order to generate the high pressure that it generates, it must what? It must be able to push up against something. So is it possible that an expansion valve could be stuck open too much that it to the point that it doesn't do its job correctly? Yes. So therefore, expansion valves can get stuck open and again compromise the compressor, like we've been saying over and over already. So therefore, that's what you're going to see there. So when you turn on an AC system here, okay, when you turn on an AC system, you're going to go ahead and see, first of all, the AC is turned off at this point right here. Okay, so the AC system is turned off. All right, so at this point, we see the pressures. All right, now if I want to do a quick check, I can see what my ambient temperature is, and I can go ahead and see that the pressure, what it is. For example, if I read my gauge here correctly on this application here, I'm at about, let's see, this is 110, so we're about 104. So therefore, we're about 104. There's my high pressure side. And I'm like, wait a minute, okay. I'm reading about what, 150, let's see, this is would be the halfways would be 175, so 160. So therefore, the pressures are not about the same here, are they? I just realized that. I didn't notice that. So what I'm trying to get across is first observe your pressures, because this system already, I should have let it actually bleed off the expansion valve, but I didn't. So therefore, when you check initially, you hook up your gauges and you haven't done anything, you're just seeing, and the system, let's say we're on the assumption that it's charged, you should see the same pressure in the high and the low pressure. So therefore, I had run this before, so I need to re-record this later, but what's going to happen is, does that pressure match the temperature pressure relationship chart, which we'll cover later? But once I go ahead and engage the compressor, what's going to happen here, turns on the AC compressor, what's going to happen? Well, the AC's turned on, the blower's set on high, right? We're at the face. We're going to kick it on. All of a sudden, the compressor kicks on. The suction does its toll. It starts to bring the pressure low, and it pressurizes up against the expansion valve on the high side. So we see about 250 right there, and we're cooling down, cooling down. We're creating a suction. And in this case, you're going to see it cools down and it continues to drop. Okay, that's normal to see. Okay, so as the engine ran further, it actually continued to actually drop. So that's a quick indication or a quick look at what the gauges are doing as soon as you turn the AC on. Now, obviously, we're going to get some freaky stuff. This is a normal. Now, the freaky stuff will be that the high side does this. It goes up and down, up and down. It just trembles back and forth between 250 and 275, let's say. Or the low pressure does the same thing as well, where that gauge is moving back and forth. So in this case, initially, when you first start off, again, you're going to look at the pressures where you start out at and the pressures you're going to once the vehicle starts to warm up. So let's say, let me color code this guy here. So let's say here that, I go ahead and turn on the compressor. I'm at 250 on the high side, but the pressure is at 60, right? And in this case, I'm at 60. So therefore, I know that it's not in the 30 to 40 range, like the pressure temperature charts were showing us on part one. I know that, okay, it is not cool in the low pressure side, because like the first slides that I showed you when we started out this presentation, the low pressure gauge is telling you the temperature of the what? Of the evaporator. So therefore, I know I'm at 60 PSI. I'm very warm right here. So therefore, we definitely got an indication that we're not actually cooling down enough. Now, the high side might be normal, right? It might be at 250. So I am generating. So why would I not? Well, this could be actual classic over oiling that I see. Over oiling has shown me, depending on much oil, either a higher than the normal high pressure side, but it could have a normal high pressure side, but we're not cooling enough. And the reason why we're not cooling enough is because we could have too much what? Oil in the system. So you're like, that's odd. It's not, no matter what happens, not getting cold because you probably have too much oil in the system. So the next course of action would be to evacuate the system, recover it, and let's see how much oil the machine pulls out of that refrigerant. And if it pulls down some serious ounces, like let's say 4 ounces to 5 ounces, even though the systems take up to 8, that's a lot of ounces to come out of the refrigerant real quick. And maybe I'm taking that for granted when I say this because this is my experience talking. Maybe I need to bring it down to basics. How much oil is it normal to see when you recover on a good system? Probably 1 to 2 ounces, and that's about it. So therefore, that's what you see. But if you see a whole slew of ounces coming out, like 4 to 6, whatever ounces, then that's a telltale that, okay, I got too much oil in the system. Now you have a choice to make here. Let's say I recovered the system, I saw a lot of oil. You could fill it and recover again. That's a waste of time, in my opinion. If it's an orifice tube style system, usually the accumulator is reasonably easy to access. I will take it out and go ahead and drain it. If more oil comes out of that accumulator, then therefore, yeah, I definitely got too much oil in the system. So at that point, I'll drain the accumulator, go ahead and put it back on. And at that point, charge the system and see if my pressures now drop. If they now drop and it's going pretty normal, then we're going to leave it alone. But if it's still, let's say it's at 45 and doesn't drop under 45 at this point, then therefore it does require another recover to try to carry out some of that oil out. And that's what you're trying to do.
Tony, got a
Okay.
question for you.
Yeah.
Got a question for you.
Go ahead.
So when you're talking about refrigerant, the weight, 7 ounces of refrigerant is the weight, correct? And then the oil, that's fluid ounces. Am I
Correct. Maybe I should have mentioned
okay?
that. My mistake. You're right, sir. You're absolutely right. Yes. Fluid ounces. Yes. Yes, that is correct. But to charge the refrigerant, we use grams or pounds for the most part.
Right. So
But
you're
for oil,
talking weight.
yeah, correct. While the ounces
Very
is in
good.
fluid ounces. Yes, you are correct. I'm sorry I did not specify that. Thank you for pointing that out. Bad me. So there you
Well,
go.
I wasn't sure either. So that
No, you're correct.
thank you.
All righty. Yeah, but again, what I'm trying to get across, because this is the most common issue I see a lot in our area, is over oiling. That's what I'm trying to get at. Hopefully that's going across there. So make sense?
Makes sense.
Okay, cool. That's what we want to get across. But what I'm trying to say is flushing has not been the solution at most times. Some people have had good luck with them, but we have so results. The best way is to drain it out because you can't take the evaporator out. You can't take the condenser out, right? You're not going to pull the compressor out to get all the oil out. Your best guy is your receiver dryer along with your accumulator. Try to get as much oil as you can out of it. And then at that point, charge the system and then run it for a while, maybe for about 15, 20 minutes, the AC system, and then evacuate again and see what you pull out at that point. So therefore, that's where your machine becomes your best friend because you are using it to carry that oil out. And that's what's causing your efficiency issues of the AC, why it's not getting cold. Now, you're probably asking once again, why has that oil been, why is there so much oil in the system? Because like I get these customers that like to buy those quick shot that has oil in them. They charge it every year. And now finally it's not working. It's not getting cold. And they finally come to you. Well, turns out it's been over oiled big time. So another thing, it doesn't happen as much because when I buy a compressor in the past, the compressors used to come with 4 to 6 ounces of oil. So therefore, what you were supposed to do was drain the oil out of the compressor before you install it to take a measurement how much oil there is in the compressor. Nowadays, there's a little tag that comes on many manufacturers of reman or new compressors that tell you how many ounces are in, if any. Some will say it only has 1 to 2 ounces, which is ideal. And some of them will come fully charged. So I see there's a few companies still selling them that way. So be aware when you install a compressor that you don't over oil it, especially if it came with a full charge 4 to 6 ounces in it. So definitely want to pay attention to that. So, okay. Questions? All righty, let me take this off. So yeah, definitely want to pay attention to that when it comes to the pressure. So, all righty. But hopefully we have made this clear. Okay. that the refrigerant itself is the carrier, and the pureness of that refrigerant with its oil is going to make it the best refrigeration system and make it last a long time. So your job is to protect that system. So if you are doing a complete AC system, meaning you're replacing the compressor, you're replacing in some cases the condenser, some guys replace the condenser, the expansion valve, and the dryers, please note that we don't know what's in the evaporator. So therefore, you can try to blow it out. You can try to see what's going on in it. But again, you need to make sure that you don't have any major restrictions there. So once the system is operating, it is a good idea to protect the system with a filter, like I said already, and make sure you actually have a good vacuum that's ensuring that you are pulling all the moisture out of the system, because that can destroy the system itself. So definitely want to pay attention to that. Okay. All righty. So with that said, let's briefly start to mention about leak detection. Now, the leaks are one of two ways. You can use the dye, or you can use your sensing bulb element, like we in other words, the beep beep sensing, or shall I say leak detector as they call it. But in this case, the problem is, where's the leak at? You're trying to find the leak. Obviously, you want to look at fittings, the front of the compressor where the clutch mechanism is at. You can have a front seal leak on the compressor around the manifold fitting that goes, or combination fitting that goes on top of the compressor. That could be the leak. But you can also have small leaks at the condenser as well. Since the condenser is exposed to the ram air that goes across it, it's been sandblasted like here in the desert, or it's actually been hit with some kind of object where it could have a very small leak. Those are the ones that test you, because the problem is you're trying to find that leak. That's where I like the dye. The dye tends to work pretty good. But like I told you already, if you have a infrared temperature probe, you can shoot it across the condenser if you can get to it. And at that point, you could see where the leaks are at, because it'll tend to run hotter or colder there. I'll ask that question here again. But therefore, yeah, you'll see those spots where the leaks are at within the passages. Now, this is a crude diagram, okay, because it's showing the old school style evaporators and condensers where it was literally tubes housed in fins. So therefore, this is old school style. This is like an R12 system right here, because again, it didn't require a lot of, R12 did not require a lot of subcooling for it to do its job. But 134A along with 1234YF do require smaller passages in the condenser and the evaporator to actually cool more efficiently. In other words, to release the heat more efficiently. So therefore, please note they're not all the same. So this is kind of a crude diagram that you're going to see there. So, all right. Make sense? Questions? All right. So when you take a look at your reading, let's go over some of the gauge readings that are important to understand here. These are various different charts out there that are going to help you out a little bit. And by the way, if you want a PDF of this, let me know. Send me an email and I'll send you a PDF of these diagrams too as well. I'll send them off to you. I was meaning to, but I didn't get to it. So let's start off with the first one. Again, the low pressure side, we see the high pressure side, right? So therefore, this is pretty dang cold there at 30 PSI on the low pressure side. We saw 220, 225. That is good. So therefore, this is a good system right here. So this is average readings with a high ambient temperature of 30 degrees Celsius, which is above 90 degrees Fahrenheit. That's not even hot for us, but some of you that's hot. But in this case, that's okay. All right. Now, what about condenser airflow or overcharge? That question's asked. Yes, this is actually, believe it or not, normal for our area. Okay, this is normal for our area. Like you saw in the previous diagram. Why? Because our ambient temperatures are very hot. Like yesterday, it was hot yesterday. So we saw 250 on the recording that I showed you. And here you could see again that we were running around 38. But the thing is, if I shoot more air across that condenser, that means I'm going to cool that condenser even further. What's going to happen on a high pressure side? It will drop. So it is under the assumption that you check the airflow across that condenser and there was no restrictions. So this would be considered normal for very high conditions that we got, believe it or not. But what should happen to that high side? It actually should, excuse me, what should happen to that low side? It should drop as it gets colder. I should see this guy drop. Now, if it's still staying high, it could be possible overcharge, slight overcharge. It could be maybe a quarter to half a pound over on charge of refrigerant in. So that's why, again, if I see this kind of dilemma, it's not dropping, then at that point, I'm going to go ahead and evacuate the system, go ahead and put a vacuum in it and then charge it with the proper charge, and let's see if the pressures drop, because it could be a sign that, again, that this system is overcharged. So I agree halfway with this chart that, yeah, this could be slightly overcharged, and only slightly overcharged, because it's still under 40 psi. It's getting cold. The 250 is about okay for our our temperatures, but again, this should drop a little bit more. Now, I want you to understand something. When you look at the high pressure side, obviously, depending if it's a cold day, if it's a cold day, let's say it's a 70-degree day, it isn't surprising to see 200 or less, right? You might see 200 or less. And this one will be very low, getting very cold. That's okay. So therefore, what's going to determine how high the high pressure side goes on the condenser side is going to be based on the ambient temperature, and again, the airflow going across the condenser. So therefore, we want to get across. Now, I said in part one, what is the danger zone of the high pressure side is 400. If you hit 400, yeah, that's not good. We definitely have a problem. So if you need a number to work with, 400 is bad when it comes to the high pressure side. That means you got either a restriction or inadequate, airflow going across the condenser, restricted condenser, or overcharged system as well. Or in some cases, we might have air. A lamp just dropped. So therefore, that could be the problem there. So definitely keep that in mind, because again, you want to make sure you do not have an overcharging condition, and also no air in the system too as well. So definitely want to keep that in mind. Get that back on. There we go. So in this case, definitely want to see that. Okay. So what's the magic number that you want to stay away from is 400. Now, some AC systems, not all, unfortunately, they don't. AC systems should have a pressure relief valve. Not all of them have them, which is kind of a stupid. So some of them will pop off at 425 to 435, depending on the application. So please note that there have been cases where a guy charges an AC system, he fires up the AC, and within seconds of running, you hear this, psh, it just releases it. That means that the high pressure relief valve on the compressor actually blew off the high pressure. So it has a safety valve, but please note, not all compressors have a pressure relief valve. And I'll show you images and stuff on those on the next class too. So we have a lot to cover too in part 3. But in this case, yeah, there is. Now, for those who don't know, there were incidents on trucks, especially GMC, Ford back in the day, that literally blew the evaporator into the passenger compartment. We saw incidents happen with that. That's where GM and other manufacturers went with the pressure relief valve to protect the system from, again, overcharging. Now, you're probably saying to yourself, well, why didn't the high pressure cutoff switch have that? Because not all systems had a high pressure cutoff switch. There is a high pressure cutoff switch that actually, again, senses the high pressure, and it'll actually cut out the compressor, so no more pressure is being built. But that was supplemented with the use of a pressure relief valve on the compressor too as well. So once again, magic number not to go over is 400 psi. Not to mention, if it is reaching because of a restriction, let's say, and it is going close to 400 psi, does that prematurely destroy your compressor as well? Yes, that's what could leave the premature life of a compressor. So I'm going after those guys that are replacing. I hope you're not one of them, but if you're one of those guys that does a compressor every year on a truck, every year this thing goes through a compressor, you need to ask yourself what took out the compressor. We talked about in part 1 about the fan clutch issues on the Cummins applications, where again they don't blow enough airflow at idle speeds. Therefore, that can destroy a compressor too as well. So please note that definitely have to have adequate airflow going across that condenser too as well. So. All righty. The opposite on the lower right here, you're going to see that the pressure drops rapidly on the low pressure side, possibly under 18, 22 psi. And you'll see that the high pressure is really low. It's because it's most likely what? Low on charge. So if they're both very low, under 150, 125, again, you see that low pressure very low, and it still is lukewarm. It won't be warm. I mean, it won't be cold. So therefore, that's telling you the system is very low on charge. So therefore, definitely, that's the easier one of both, where they're both low. And they're both very low, definitely low charge. But what about a weak compressor? Yeah, we can get weak compressors. So in this case, we can see that we're not generating enough suction. That's what's going on here. We're not sucking down enough, and we're not pressurizing enough. So in this case, we see that the compressor could be the weak link here. Now, if they're both about the same and the compressor's engaged, I believe we had a question last week about that. That could be a stuck open thermostatic expansion valve, but it could also be, again, the reed valves in the compressor or one of the pistons in the compressor might be going out. So therefore, we're not pressurizing enough, or we're not, again, pretty much generating enough suction. So I guess what I'm trying to say is, yeah, this is a very high low side pressure, and this is a very low side high pressure. So we're not pressurizing enough. And again, we're not sucking down enough, because as we pressure drops, we're creating more of a suction, lowering the boiling point. So therefore, we definitely can see that this is a compressor issue, definitely. Now, this is all under the assumption here, before you start judging the compressor, that the vehicle, excuse me, that the system is properly charged with the correct amount of refrigerant in there. So definitely want to pay attention to that. Okay, definitely want to pay attention to that. So, okay, any questions? Now, there's more gauge readings I'll go over later on, but in this case, these are the practical, more basic of them all. So therefore, I guess what I'm trying to say is you need to get an average of good known. So if I saw a guy do this on his machine, he actually had a good known reading. So what he did is he actually put a highlight mark on his recovery gauge on where his average number should be. So he took a known good vehicle and actually marked it on his gauge itself. He used an erasable marker on it so he can know where he's supposed to be. And then now he actually knows them by heart where the reading should be on the average, depending on ambient temperature, obviously, because if it's a very hot day, it's going to be different than a cool day. So therefore, please be aware that cool days, your reading should be lower substantially than versus a hot day like I just showed you there. So, okay, definitely want to pay attention to that. So that's it there on that. All righty, I'm running a little bit early. Any questions there? That's what I wanted to cover with you. Please ask any questions. Questions? No questions, huh? All right. The next thing I wanted to mention, which I'm going to give you some, I actually took some recordings. I had some images, but I didn't like them. I deleted them. Sorry, but Tony's very picky. But in this case, what it is that let's go back to the compressor here. Let me go back here. All right. What we'll talk about in part 3 is going to be more enhanced electrical and the HVAC controls I'll cover too. So we got a lot to cover there. But on the compressor, okay, the first thing you got to understand is we have a clutch mechanism, and that clutch works with a certain amount of voltage and amperage. Okay, so they do, do suck a lot of amperage. So if you ever saw a lab like the way I have when I was working with GM, I got to see the labs where they test compressors, and they literally cycle on and off that compressor clutch millions of times to test the endurance. So when I see compressors that are installed and the clutch goes out within 6 months of operation or 3 months of operation, a lot of people say, well, it was a defective compressor. Maybe, but it could also be that we had inadequate voltage going to the compressor. So therefore, we have to take a meter and measure the voltage drop across that compressor clutch connector. You have to do it at the compressor clutch to ensure you don't have any unwanted resistance either in the relay or the wiring going towards the compressor. So do me a favor. If that compressor is replaced, you need to find a way to get some probes or some leads in there and do a voltage drop test across the compressor. So if it's 14.2 at the battery, guess what you should have ideally at the compressor? You should have around 14.2 as well. Some of us are at the opinion that if I'm doing a compressor, I'm going to replace the AC compressor clutch relay, because that relay contacts could also be compromised with excessive resistance and cause a voltage drop there, in turn restrict the amperage going to the clutch itself. So therefore, definitely want to put a voltmeter across that compressor clutch to make sure that it's, again, not have a voltage drop, because the voltage drop is a way of us understanding, is there high resistance causing low amperage going to that compressor itself. So therefore, please remember that. So I cannot stress that enough. Make sure you do that. Just because you jump the relay and you engage the clutch doesn't necessarily mean you got a bad relay. You also should do a voltage drop once again across that compressor clutch, because if amperage is low going to that compressor clutch, what's that clutch going to start to do? It's going to start to slip. So therefore, you got to understand what's going on with the temperature pressure. So let me backtrack a lot of slides, okay? We're going to look at the pressure temperature charts here, okay? Now, this is a high pressure side reading, okay? And if the temperature is very warm, we might see excess of 300 psi. So I guess what I'm trying to say is if the truck and car has been sitting in a parking lot 6 hours, let's say, and it's 110 degrees outside, like us here right now, okay? When you get in the vehicle, you open the windows, you try to get that high heat because it's hotter in that compartment than it is outside. You open the windows, you fire up the vehicle, you turn on the AC. Here's the question. What is the pressure that compressor is engaging when it starts to rotate? In other words, what's the pressure? Because on one hand, he's going to pressurize, but on the other hand, he's going to suck. So therefore, he's going to hit hard those pistons on a high pressure. So the disadvantage of 134A and also 1234YF is that as that refrigerant that sits underneath, you got to understand if it's outside. I mean, let's look at it realistically. If the temperature outside is 110, what is the temperature in that engine compartment? Obviously, in excess of 110. So that means that refrigerant is in excess of 300 psi plus. It's so hot. So therefore, that compressor is going to kick on and fight how many pounds of pressure that's already in there, right? So therefore, it's imperative that clutch, bam, engages solidly because he's going to be fighting some serious pressure initially. So therefore, I call it the shock there. It's shocking that compressor. So therefore, we need to make sure that clutch engages solidly. Your job, again, is to do that voltage drop test that I mentioned earlier, okay? To ensure that clutch has no unwanted resistance in its circuit, so it gets the full amperage it's supposed to get. Now you can go ahead and put an amperage gauge ammeter on that one of those wires, but I prefer you do a voltage drop test because that is telling me if I got unwanted resistance in the circuits or in the relay. Okay, can't stress that enough. So therefore, definitely put a voltmeter across it because again, these poor compressors are getting beaten. So what happens? If there's less amperes than what there should be going to that compressor clutch, that clutch is going to start slipping intermittently with that friction as that belt is driving that compressor along with that clutch. And if it's slipping, what is the temperature now? Because that friction is generating some hellacious heat. And it gets so hot as that friction goes that it'll actually seize the front bearing of that compressor and the clutch assembly, not to mention fry the clutch. So therefore, friction is a big enemy there because, I call it the pancake effect. Bang, it engages, but it should stay engaged. But if it's slipping, then therefore we definitely got a problem there. So again, voltage drop testing across that compressor clutch is very imperative as you're testing it too. Since we're on the subject of, talking about voltage drop testing, it is also a good idea to make sure that your blower motor, the fan assembly is also getting full voltage too as well. So if you're on high, please note, whether it being a relay or whether it being a module, the blower motors themselves also need full battery voltage to get full speed. So it's a good idea also if you can access either from the bottom or the outside, depending on the design, if you can get to it, it is ideally also to do a voltage drop test across the blower fan to make sure that it's getting full voltage and full amperage at the high speeds. Because again, you're trying to ensure once again that there's no unwanted resistance. Some models use a relay, some models use a module. I know, I get it. But in this case, or a blower motor resistor too as well, again, you got to make sure it's getting full voltage. So again, if the voltage on the truck as it's running is 13.4, what should I see at the blower motor? Ideally 13.4. Yes, I know there is a quarter of a volt variance. You have a leeway, but if it's like 13.4 at the batteries and you're getting no more than 12.2 at the blower motor, then you've got a problem in the circuitry. And the first guy you want to go after is the relay, right? You want to make sure the relay's not a problem. So we'll review circuits as we move along there, but all I'm saying is that pay attention to that. Definitely want to do those voltage drop tests across the compressor and also across the blower motors to make sure they're getting full power, because again, that could lead to premature life of the blower motor, inadequate, well, sort of premature life of the blower motor, but not adequate air going across the face. And also the compressor can be compromised at that point. So makes sense? All righty. So therefore, definitely electrical checks. Definitely want to discuss that on the I want to know that when you do testing. So you're trying to ensure. So I guess what I'm trying to say is when I do a complete AC job and I've done the compressor, it is my goal that AC system will live a long time, at least 4 to 5 years, minimum 4 to 5 years. So yeah, it should live that long. And if it doesn't live that long, either I had deficient parts or defective parts, or B, I didn't do my proper checks to make sure there's no contamination, there was no moisture, that I made sure I had a good voltage going to the compressor and so on. So therefore it is a clean refrigerant system, and the desiccant or the receiver dry accumulator were doing their job. So definitely should see a long time. I don't need to tell you, by the way, before I forget, in servicing of a 134A system with PAG oil, you all know that PAG oil is hydroscopic, correct? So therefore, a lot of us use mineral oil to put on the O-ring. So do not put PAG oil on the O-ring seals, because again, that is hydroscopic. It absorbs moisture. So therefore, it'll attract moisture. That's why in some very humid areas, we have seen growth or mildew around fittings. That tells me that somebody put PAG oil around the O-ring. So therefore, you do not use PAG oil, on O-rings to lubricate them. You use what? Mineral oil. And you can still buy it at your local auto parts there too as well. So keep that in mind. So that's about it. I'm at 10:17. I'm about a few minutes early. Any questions? Questions? Is this
Nope.
information helpful?
Pretty
Feedback?
thorough.
I'm sorry?
Pretty thorough. Thank you.
All righty. I'm not done yet on part 3. We're going to cover a lot more. Any other comments and questions? If you don't want to speak, you're welcome to hit the chat window. Hopefully that helps you. Yes, no, yes. Any questions, comments? Well, I guess we can end it here. Since I am making sure that this recording does not go with a hiccup. Those of you that want a copy of the link that I had to put on YouTube, I'm sorry I had to put it up there on YouTube. If you want part 1, definitely. But part 2, I'll send you a link through Zoom. That should be working. Hopefully I resolved that issue. You should get this recording too. And next week we're going to do part 3 and cover more AC. Hopefully this has helped you. I mean, has it helped you? A little bit? Yes, no? Like to get some feedback. Okay, well, all right.
Yes,
It's
it's been a
hear.
long time since I've had any instruction.
So has it helped?
Certainly does.
Okay, that's good to hear. All righty, thank you. Okay, so I'll send Dynamic Diesel once a PDF. I'll send you those diagrams later on. I'll put them up on there for you to have. So definitely will send you that PDF there from Dynamic Diesel there. So cool. Last minute, any questions there? Because I gotta get out of here and I gotta go to the hot. I gotta go out to the hot. So, all right, guys, no other questions? All right, with that said,
Nope.
then I will see you next week.
Okay.
Take care.
See you, Tony.
All righty, bye-bye.